Okay, in this lecture, we are going to be going over point estimate and confidence intervals. This is chapter 9. You're going to be able to compute and interpret a point estimate of a population mean and compute and interpret a confidence interval for a population mean. So oftentimes we don't have the entire population. It's really easy if we have the entire population, we can just calculate the mean, but often we can use really high quality sampling with a large sample size to give us what's referred to as a point estimate, or a static number or static value computed from sample information that estimates a population parameter or estimates a population mean. So, for instance, the Bureau of Tourism in Barbados wants to estimate the mean amount spent by tourists visiting the country. You see this all the time with, the average person spends this much when they go to Disney World. Well, does Disney track every single credit card, transaction? The answer is no. You poll 500 people and you see how much do they spend at Disney World. And they make sure that their measures are extremely accurate, and that their sampling methods are really precise. And so when you do this, then you use the mean of those 500 people to serve as an estimate of the unknown population parameter, otherwise known as a point estimate. So a point estimate is just an estimate that you make based on a really high quality sample. Okay, so a confidence interval is a range of values within which the population parameter is expected to occur. So you've got this confidence interval, which is constructed from sample data so that the population parameter is likely to occur within that range at a specified probability. The specified probability is called the level of confidence. So there's a few things that can influence the level of confidence that we have, or influence the width of the confidence interval. And that is, number one, the number of observations in the sample. Okay, so the greater number of observations that we have in the sample, the smaller the confidence interval is going to be, which is a very good thing. Okay, so we want to have increased confidence without sacrificing anything else. One of the ways to increase confidence without sacrificing anything else is to increase the number in the sample. Also, the variability in the population, usually estimated by the sample standard deviation. If you have a smaller variability, it's going to decrease the confidence interval, and also the desired level of confidence. If you want 95% confidence, it's actually going to make a larger confidence interval as compared to, say, 90% confidence. It's going to be a smaller interval, and we're going to get into that in just a minute. So to determine the confidence limits, when the population standard deviation is known, we use the Z distribution. And what we're talking about now is the limits. Plus or minus a certain Z score is the limit, and that Z score coincides with an actual value. Okay, so in order to calculate the confidence interval for a population mean with the population standard deviation known, we need the sample mean, which is X bar. Okay, then we also need the Z score, or the Z value, for the particular confidence level that we want. We need the population standard deviation and the number of observations in the sample. Make sure you guys write this down. You will need to know how to do this formula. So X bar plus or minus Z, or the desired level of confidence, multiplied by the standard deviation divided by the square root of n. So let's take an example. We have, first of all, I want to differentiate between a couple tables. Okay, prior to this, I've given you guys some different tables. I've given you guys on the Unit 2 formula sheet, this is the table that I gave you, right? And we also used this in the last lecture. And so this right here gives you the value that's less than or greater than less than a negative z value and greater than a positive z value. However, what we want now is the area under the normal curve. So we want this area right here, and we also want this area right here. Now you could do the complement rule, or I could just give you a new z-chart that gives you the area under the normal curve. And then you don't have to calculate anything. Okay, so that's what we're going to do here. So we want a 95% confidence interval. And what that means is we want the mean value that we calculate. We want to have confidence in that value. 95% confidence in that value. In other words, 95% of the values will occur, or 95% of the mean the means of the samples will fall within this this range. Okay, so or we've got a 95% confidence that this is that the population actually falls within this range. So in order to do that, we need to look at this particular number, which is 0.4750. Now what happens if you multiply 0.4750 by 2? If you multiply that by 2, what you get is 95. So if you have a value in the middle here, then the probability that an individual or a sample or the population mean will be within plus or minus 1.96 standard deviations of the point estimate mean will be plus or minus 1.96 standard deviations. Okay, so that's really important because you got 47.50, 1.96. And we want to know what is the probability that an individual or that the point estimate will be within is accurate, right? We want to know what is the confidence level that we have that it is accurate. And so when somebody asks you, how much confidence do you really have that you are correct? Well, I'll tell you how much confidence I have that I'm really correct. I did a really good job sampling. I used high quality sampling procedures, and this was my mean that I had. This was the standard deviation that I had. I had a high number of individuals in my sample, and so I used those statistics to first of all estimate a point estimate of this amount for the mean, and then to estimate a confidence interval to saying that this is the values 95%. I've got a 95% confidence that it will fall within this very specific range, that the actual population parameter will fall within this very specific range. So an example of this is the American Management Association studies the income of store managers in a retail industry. A random sample of 49 managers reveals a sample mean of 45,420. The standard deviation of the population is 2,050. And so we've got 45,420, 2,050, and 49. Okay. So first of all, what is the population mean? We don't actually know the population mean, so we're going to do a point estimate. The point estimate that we're going to use is 45,420 because that's the sample. So what we want to do now is we want to say, what is the confidence? How much confidence do we have that it's actually 45,420? Okay, so we're going to use a 95% level of confidence right here. And we're going to use the equation x bar plus or minus z multiplied by the standard deviation divided by the square root of n. So once again, we have n, it's 49. We have the standard deviation, it's 2050, and we have x bar, which is 45,420. And we also have Z. Z is 1.96 because we're doing a 95% level of confidence. You could, like I said, do a 90%, or you could do a 99%. You can do whatever level of confidence you want, but those are really the standards. 95 is normally the one that you're going to use the most. Okay, so you do 45,420 plus or minus 1.96, which once again, this is the Z-score for 95% or 47.475. 1.96 multiplied by 2050 divided by the square root of 49. The square root of 49 is 7, and so 2050 divided by divided by 7, I can calculate that really quick, is going to be $292 and 86 cents. Okay, $292 and 86 cents. Okay, so then you multiply that by 1.96, and more or less what that gives you is 574. 574 above or below 4,542 or 45,420. So the confidence interval, or the range of I've got a 95% level of confidence that the population parameter for the mean resides between 44,846 and 45,994. So the value of 574 is called the margin of error. So I've got a margin of error of $574. So how confident am I? Or better yet, what is the population mean? Okay, I have a 95% level of confidence that the population mean is $4,542 or $45,420 plus or minus $574. Or I have a 95% confidence that the actual population mean is between 44,846 and 45,994. So that is level of confidence with the Z-score, and yeah, that's the end of this lecture.